We have learned how to solve equations containing one radical. We're going to build on that just a little bit and now learn how to solve equations containing two radicals. Here's the key. When solving an equation that contains two radicals, first isolate the most complicated radical and square both sides. Then solve the resulting one radical equation just as we learned previously. So we're going to eliminate the radicals one at a time. Let's try this on example 2. Solve the following radical equations and don't forget to disregard extraneous roots. So in this case, the most complicated radical is our first one. So that's the one I want to isolate. So I'm going to add square root of x to both sides and we'll have our most complicated radical isolated. This gives us square root of 2x plus 1 equals 1 plus the square root of x. Now that we have one of our radical isolated, we can cancel it by squaring both sides. So on the left side, we have the square root of something squared. Those are inverse operations and they cancel out, leaving behind the radical 2x plus 1. Now be very careful on the right side. As we saw in the previous lesson, we don't want to distribute that exponent. So to make sure we understand what we're doing, I'm going to take that term and write it by itself twice. Then we can FOIL it out. So the product of our first two terms here is 1. The product of our outside terms gives us square root of x. Inside terms, another square root of x. And last terms, we have square root of x times square root of x, which is square root of x squared, or just x. Notice we have two like radicals here in the middle. So we'll combine those on the next step. We have 1 plus 2 times the square root of x plus x. Now, while we successfully eliminated one radical, we still have one radical that remains. So we want to isolate that and then square both sides. So now my focus is to get this term by itself. To do that, I'm going to subtract x from both sides. And let's subtract 1 from both sides. On the left side, we end up with 2x minus x, or x, and 1 minus 1 is equal to 0, so the 1's cancel out there. And we have equal to, on the right side, 2 square root of x. Now, at this point, you could choose to go ahead and divide both sides by 2 and then square both sides. That would technically isolate the radical. But I think it would be easier at this point just to square both sides, handling that product on the right side with care. So I'm going to square the left side and square both factors on the right side. This gives us x squared equals, now we're going to square the 2 to get 4, and we're going to square the square root of x to get x. Now notice I am distributing the exponent here because we're working with the operation multiplication. You cannot distribute the exponent here because you're working with a sum. So make sure you know that really important difference. Okay, so after eliminating both radicals, notice the type of equation that we end up with is a quadratic equation. So this one we can solve by factoring, but first we need to get it equal to 0. So we'll subtract 4x from both sides. We can factor out our greatest common factor of x. That leaves behind the factor x minus 4. And then set each factor equal to 0, including that little monomial term, and solve for x. So we have two apparent solutions, x equals 0 and x equals 4. But with the case of radical equations, oftentimes we get extraneous solutions. So I'm going to plug 0 in for x in the original equation and make sure we get a balanced equation. So in this case, we end up with the square root of 1 minus the square root of 0, which is 1, or 1 minus 0 equal to 1. So x equals 0 does balance the equation. Let's check out x equal to 4. So we have the square root of 2 times 4 plus 1 minus the square root of 4. We want to know, is that equal to 1? So under the radical here, we have 2 times 4, or 8 plus 1. That's the square root of 9 minus the square root of 4, or 3 minus 2, which equals 1. So in this case, both of our solutions worked. We can present them formally as a solution set, with the values 0 and 4. Remember, with radical equations, when you get multiple solutions, sometimes they all work, sometimes you got to throw one of them out, sometimes neither of them work, but you can always verify by substitution. Let's try this process again on example B. We have two radicals in our equation, so we want to isolate the most complicated radical. So I'm going to move this whole term to the other side by adding it to both sides. So we have square root of 5y plus 1 equals 2 plus the square root of y plus 1. Now that we have one radical isolated, we can eliminate it by squaring both sides. The left side is pretty easy. The square root and the square cancel to give us the radicand 5y plus 1. But on the right side, I'm going to take my time. Again, we cannot distribute the exponent across the sum, so we're just going to expand what that exponent tells us to do, that is multiply that base by itself twice. And then we can FOIL out the right side. Now, we're just foiling, but this one is a little more complicated than normal. So let's go through it. The product of our first two terms here, 2 times 2, gives us 4. Then we're going to multiply our outside terms. So for the outside terms, we have 2 times this radical. So we're just going to write it as plus 2 times the square root of y plus 1. Multiplying our inside terms, we have this radical square root of y plus 1 times 2. Well, that's the same as our outside terms, 2 square root of y plus 1. And then finally, we can multiply our last terms, square root of y plus 1 times the square root of y plus 1. Remember, when you multiply a radical by itself, it cancels that radical, at least for a square root, so that gives us y plus 1. Let's clean this up a bit, and we'll see if we can assess what we're dealing with. So we've got two like terms, or two like radicals here. So we're going to combine like radicals, and we do that just by combining their coefficients. So we get 4 square root of y plus 1. So we were successful on round 1. We eliminated one of our radicals, but we do have a radical left in the equation. So I want to work on isolating that radical. So actually, I've got one more little step I can do here. Didn't pick that up first time around. Let's combine those constants. And let's call that 5 plus 4 square root of y plus 1 plus y. Okay, now we are ready to start moving things from one side to the other. So I want to get the radical by itself. So I'm going to subtract y from both sides. And let's get rid of that constant and subtract 5 from both sides. And now we have 4y minus 4 equals 4 times the square root of y plus 1. All right, this one's working out pretty conveniently. Notice everything is divisible by 4. So let's go through and divide all of our terms by 4. Now these two are connected by multiplication. So that's one term. I'm going to divide it by 4. And I have 2 terms over here on the left that we need to divide by 4. So that's going to lead us to, let's see if I can use some space up here. 4y divided by 4 gives me y. And negative 4 divided by 4 gives me negative 1. And on the right side, I have the square root of y plus 1. All right, we're in good shape. We're ready to eliminate our other radical. And we're going to do that by squaring both sides. Okay, be careful on the left. We want to make sure and FOIL it. So let's call that y minus 1 times y minus 1. And on the right side, the square root and the square cancel, leaving behind y plus 1. Okay, hang in there. We're out of the woods. We don't have any radicals left. But now notice we're dealing with a quadratic equation. So let's work on solving this quadratic equation. How do I know it's quadratic? Well, look, when we FOIL here, we're going to get y squared. Outside and inside terms make 2y. Product of our last terms is plus 1. So now it's obviously quadratic. So our goal is to get it equal to 0. So I'm going to move all of my terms to the left. So let's subtract y from both sides. And let's subtract 1 from both sides. It's going to cancel there as well. So we end up with y squared minus 3y equals 0. Not bad at all. We can solve this quadratic equation by factoring out the greatest common factor of y. It leaves behind the factor y minus 3. So we have two apparent solutions, y equals 0 and y equals 3. Just to be sure, let's double check both of our solutions with substitution. So plugging 0 in for y, we have 5 times 0 plus 1 under the radical, minus square root of 0 plus 1, and we want to find out, is that equal to 2? So our first radicand, 5 times 0 plus 1 is 1. Looks like we have the square root of 1 minus the square root of 1. That is not equal to 2. We would have 0 equal to 2. So y equals 0 is an extraneous solution. Let's check 3. So if I plug 3 in for y, we have 5 times 3 plus 1 under the radical, minus the square root of 3 plus 1. We want to find out, is that equal to 2? So under our first radical, we have 5 times 3, or 15 plus 1. That gives us 16. Second radical, we'd have square root of 4. The square root of 16 is 4, and the square root of 4 is 2, and that one does give us a balanced equation. So we have one solution on that one. I know that was 18 or 19 steps. It felt like a lot more, but you've got to be precise on each step. So that's a pretty challenging equation, because if you come back up here, let's say I just miss one sign or something like that, it does affect the whole problem. So take your time on those, be meticulous with the FOIL, and don't forget to check for extraneous solutions. All right, best of luck to you on two radical equations on the homework.